Greetings, physics family. We're going to go over 7-2. Let's do problems 1 and 2 in this worksheet for this video. So it says, it is said that Galileo dropped objects off the Leaning Tower of Pisa to determine whether heavy or light objects fall faster. If Galileo dropped a 5-kilogram cannonball to the ground from a height of 12 meters, so we got a 5-kilogram cannonball, a height of 12 meters, what is the change in potential energy? Okay, so we know that if we're looking for potential energy, that has to do with mass times gravity times height. So let's just write down what we have so far. We know the mass is 5 kilograms, and we also know that the height of this drop is going to be 12 meters. Perfect. We want to know what the change in potential energy is. Now, once it falls to the ground and it's on the ground there is no potential energy, right? It's sitting on the ground, so there's no height anymore. So really all we have to do is figure out what is the initial starting potential energy in this case. And we know potential energy is just mass times gravity times height. So now that we have that equation, let's plug in and solve for that. Well, my potential energy is going to be the mass, which is 5 kilograms, times gravity, which is 9.8. And in this case, we're not using a negative. We're just keeping things as quantitative without direction, just to get a total value here. And we know that 12 meters is the height. So when we do mass times gravity times height, plug that into your calculator. What you end up getting is about 588 joules. Now, if you wanted to look deeper at this, said, wait a minute, it did say, what was the change in potential energy? Well, the potential energy change in would really be final minus initial. But remember, since the final energy, the ball would, or whatever object would be on the ground, there would really be no final potential energy. So when we solve for the potential energy, that really tells us what the change is in because it went from 588 to 0. So in the end, the total potential energy to start with was 588 joules, simply using the equation we had up here. Perfect. Now let's move on to question number 2. Question number 2 says, in 1987, the Kentucky Derby winner, Elisheba, ran the race at an average speed of 15.85 meters per second. All right, so right off the bat, that looks like I am given a velocity. So I'm gonna write that down. I don't know if I'm gonna use it, but I'm going to write it down because it's given to me. If Elisheba and the jockey have a combined mass of 550 kilograms, all right, well, mass is important usually. So let's write that down, 550 kilograms. What was their kinetic energy as they crossed the finish line? So let's look into that really quick here. It looks like I want to know my kinetic energy. And sorry for me stumbling over my words. If I want to know the kinetic energy, let's look at my equation. My equation is 1/2 mass times velocity squared. All right, I can plug into that because if I'm looking for kinetic energy, 1/2, I've been given the mass, which is 550. That's the horse and the jockey. And my velocity squared is 15.85, but I'm going to square it. We just need to plug that into our calculator to solve for it. So if I do 1/2 times 550, that's 225. And then don't forget, 5.85 is squared. So make sure you square that first and then multiply it in. Otherwise, if you don't put in parentheses, careful, the computer might get slightly confused. But in the end, what I come out to is about 69,086.19 joules of energy. Right? And that should be quite a bit of energy because a horse and a jockey is quite a mass. And remember, you have kinetic energy if you're moving. So it looks like we solved for that one. Awesome. That was 1 and 2 of 7-2. Go ahead to the next video if you want to look at question number 3. Question number 3 is going to tackle the idea of the conservation of energy. The idea that the potential energy you start with and the kinetic energy you start with is equal to the final potential energy you end with plus the final kinetic energy that you end with. Remember, Energy is neither created nor destroyed, so the total energy to begin with has to be equal to the total energy you end with. But go ahead to the next video to look for that one, and we'll go through those steps. Take care.